Okay, so for today, I'm going to be taking you through two ways to quantify inequality. This is important because it's not very easy. I should say it's possible to observe inequality around you and to even see anecdotal evidence of inequality, right? To notice somebody not making as much money as someone else, which is what we're going to be talking about directly here, or even inequality in outcomes as far as someone in a neighborhood not having the same outcome as someone else, even though they may have similar economic characteristics but live in different neighborhoods. So, when we want to discuss this in a way where it's measurable and therefore in a way where if there is improvement or degradation in the amount of inequality, that we can detect it. We need to have a way to actually quantify what's happening. So the two approaches that are most typically used in quantifying inequality are called the Lorenz curve, and it's another way to do it, but it's also kind of a component of the Lorenz curve, the Gini coefficient. So the first thing I'm going to show you here is how to set up what we call a Lorenz curve. If I scroll down, you can see that the Lorenz curve has on its y-axis the cumulative percentage of income, and on its x-axis the cumulative percentage of the population. This curve is trying to measure what proportion of income a certain proportion of the population has. For example, are people in the top 1% of the population controlling or earning substantially more income than the people at the bottom 1% are? You would assume yes. Even though they both represent 1% of the population, you would assume that the top 1%, by the fact that they are at the top of the income distribution, are in control of more income than the bottom 1% would be. The way we graphically show that is by showing a Lorenz curve that will, for example, at when we talk about 20% of the population in this hypothetical economy, we know that they control 0.2% of the income in our hypothetical economy. So despite being a fifth of the economy, they are only in control of less than 1% of the income, or they're only earning less than 1% of the income. Most of the Lorenz curves are shown to you with a 45-degree line drawn through it, which is basically a line of equity. The line drawn through at 45 degrees should represent the point where 20% of the population would earn 20% of the income. The 45-degree line, in that sense, then is just something relative for you to observe how unequal the society is compared to that red line. Our hypothetical economy, in a perfectly ideal and equitable world, would have its blue line drawn right on top of this red line. So you can tell that the distance between the blue and the red line represents the amount, the burden of inequality that exists in this economy. And the more bowed down this curve is, the higher and higher the degree of inequality. So how did we even build this so that we can get a Lorenz curve together to see how unequal our society is? The first step, if you follow me from column A to the right, the first step is in grouping people. So maybe you would want to segment. The more you can segment your economy, the better. If you can talk about groups of people in terms of a household, that is better than talking about groups of people in terms of thousands of people, let's say, or even hundreds of people. The more minute you can get down to, the better an idea you'll have of the level of inequality. In a perfect situation, we would be talking about individual incomes, and we would then take every step throughout the rest of this example, you looking at people as individuals. So in this example I've shown you, we have a very ideal situation in that our economy only has 10 people in it. And we can look at the incomes of each of those 10 people effectively individually because each group of 10 or each of the 10 groups only has one person in it, as you can see in column B. In column C, we see what the group's average income is, and since each group only has one person in it, we can see that the average income is basically the person's income, that individual's income, in our 10 individual economy. First thing that you have to do when you're building a Lorenz curve is to lay out all of your all of your buckets of people in order from those making the least to those making the most. Again, this would be more complicated if we were doing this with multiple people in each group. But in this case, since they're all individuals, what we've basically done is taken all 10 people in our economy and laid them out, starting with the first person who only makes $1,000 in a year to the last person who makes $1 million in a year. You can see that the total income is the same as the average income because the total income is just multiplying the income in average in the group times the amount of people in the group. In this case, that's 1. Once you do that, you'll have an idea of what the cumulative income is as you go from lowest earner to highest earner. So in column E, for example, we start off with the cumulative income with the first person, which is only $1,000 because there's one person and they earned $1,000. When we get up to the second person, the cumulative income now is increased to $3,000 because we're now talking about the income of both the second person who's making $2,000 and the first person who's making $1,000. Cumulatively, they make $3,000. Next person, we're talking about accumulation of $10,000 because the third person made $7,000, $7,000 plus the prior $2,000, and then the $1,000 before that all add up to $10,000. When we get to the end of the line, we see that in total our economy has $1.5 million in it, with 1 million of that earned by the single person at the very top. So you can already get an idea of how this is demonstrating to us the amount of inequality in our society, because what we're learning by putting this data in order, or putting these people in order from lowest earner to highest earner, and then adding up the cumulative income as we go from person to person, we're getting an idea of how much of the total income in our society is held by the bottom 10%, which would be the first person. The bottom 20%, which would be row 3, which is $3,000, right? The bottom 30%, and so on and so forth, until we get up to the bottom 90%. And then we can tell what the difference is between the bottom 90% and the top 10%. So by laying this out, by having accumulation of the income, we get an idea now of the difference in the proportion of income held by one side versus another side. And we can then also compare this to the accumulation of the population, right? So now when we talk about what proportion of the population holds what proportion of the income, first part of that is understanding what the proportions of the populations are. So we can tell from column F that once we get up to like the fourth person, right, we're talking about 40% of the cumulative population, because that fourth person represents themselves as well as the 3 other people before them as a cumulative of the population going in order. We have an idea now of what the cumulative percentage of the population is going down the groupings, and because each group has one person out of 10, right? That one person represents 10% of the population. That's why every time we go from person 3 to person 4 to person 5, we're adding 10% to the cumulative population total. By the time we get to the 10th person, they represent them, and everybody before them represent the total population for the society. So now we have some very important information here to compare, right? We have the cumulative income earned up to the cumulative percentage of the population. And we know that at 100% of the population holds $1.5 million. But before that, the amount of income held by each percentage of the population is really interesting, and that's the distribution that we care about. So how do we formulate this all into what comes out in this Lorenz curve here? First, I have a column G that shows a hypothetical economy's distribution of income. What is column G doing? Column G is taking how much income is earned by the first person in the economy and dividing that by the total income in the economy. So for example, the first person here only holds 7%. They only hold 0.07% of the total income in the economy. Out of $1.5 million, they hold $1,000. As we go on, the cumulative percentage of the distribution of the income is going to increase. So the bottom 20% of the income distribution earns 0.2% of the total income, which is the $3,000 out of 1.5 million, and so on and so forth, right? When we get to the bottom 50% of the distribution, they hold 4% of the income, which is $60,000 out of 1.5 million. And then so on and so forth until we get to the 90 percentile, right? So 90% of the economy holds 33.3% of the income, which is the $500,000. They basically hold, the bottom 90% of our hypothetical economy holds a third of the income. And then we can see that there's a huge jump between the bottom 90% and the top 10%. So the difference between these two is the amount of income held by the top 10%. And this is where the problem, or this is where understanding inequality becomes very vivid, because now we can show that the top 10% are taking over 70% of the income, really, if you round it in any direction. And then the bottom 90% are holding 30% of the income in the economy, or are left to split up 30% of the income in the economy. The other column that I have here is just how we decipher equity. And of course, equity would be 10% of the economy owning or controlling 10% of the income, and so on and so forth, until you get to 90% of the income in the economy being controlled by 90% of the population. So this is how we formulate or inform what goes into this Lorenz curve, which is why this Lorenz curve has it's a curve that does seem to exponentially grow at a point, but it's very slow in takeoff. And that slowness and how it takes off it's evidence of how bad the inequality is, because the Lorenz curve should theoretically take off very rapidly and exponentially in a perfectly equitable society. That's what the red curve is doing. But the Lorenz curve lingers at the bottom of the y-axis for a while. It lingers there because the bottom proportion of our population is in control of very little of the income. And while it does start to rise after a while, the sharpness in how it takes off from the 80% to the 90% to the 100% represents how much the top 20% of the distribution disproportionately is in control of the income. The fact that they are in control of so much of the income is why the takeoff in this curve is so slow at the bottom. Now that you've seen that, we need another quantitative way to describe the difference between equity and what's happening in our economy. And that is something that we would call the Gini Coefficient. The Gini Coefficient is roughly a measure of what percentage of all the space under the equity line in this graph, what percentage of that space only exists below the blue line. So if we were to take the entire space under the red line as a huge triangle, and then try to figure out what percentage of that triangle only exists below the blue line, the space that's underneath the blue line. Why do we want to know that? Because the opposing space, which is the space between the blue line and the red line, is the size of the difference between equality and what our society is experiencing. And we want to know how big that size is. The bigger the size of that difference, the more unequal we know our society is. So to get to that point, we need to understand a couple of things first. We need to first know what each person's represents as far as a fraction of the population. That's easy because we're working with groups of one person. So out of our 10 people, each person represents 10% of the population. Next, we need to know how much or what fraction of the population is richer than the person who we're observing currently. So to break that down, if we were to observe the first person in our income distribution, they represent 10% of the population. And that means that 90% of the population is richer than them. As we go on, they are a 10%, or they decrease the percentage of the population that's richer than them by 10 percentage points, which is why we go from 90 to 80 to 70 to 60 to 50. It makes sense. But where this becomes interesting is what fraction of the total income is controlled by each person. So despite being 10% of the population, the first person controls 0.07% of the income. We kind of gathered that because when we looked at the hypothetical distribution, we were looking at it in such a way where we know what the first person was dealing with. We knew they had 0.7% of the income. But as you can start to see, the other numbers are different from the numbers in column G because we're not talking about the accumulation in column K. We're talking about what does this individual person, as an individual, how much of the income do they control? This is how we get to the point of knowing that the top person controls 66.67% of the income. The lowest person controls 0.07% of the income. Now, person number 5 controls 2.33% of the income. Person number 6 controls 3.33%. And person number 7 controls 4%. So as we go up here, these people control gradually more of the income, which would make sense if we're really splitting these people up and putting them in order by who makes the least to who makes the most. Then as you go along the line, you should expect that people are going to have a stronger control over the income than the person right before them. How strong is what determines the level of inequality. We take this information and then we kind of plug it into an equation that, without getting into the real mathematical specifics of it, the equation basically tries to weight the fraction of the income that you control by the fraction of the population, and then tries to contrast that to what would be equity in this population. So the fact that the bottom person only controls 0.7% of the income means that they have a lower score, let's call it, in getting to the Gini coefficient than the person who controls the top. What we're left with after working through this equation is an aggregate score of 0.25, which is the space underneath the blue line. And therefore, if we were to just take the number 1 and subtract the space underneath the blue line from that, we would have the space above the blue line, which is what is the Gini coefficient, which is 0.75. Now, the Gini coefficient is important because we can quickly tell someone what the level of inequality is in any economy by just quoting to them what the Gini coefficient number is. And you'll see this in a second when I start to play around with these numbers. But 0.75 is actually very close to what the actual Gini coefficient is for New York City when you lay out the individual taxpayers in the city from least to highest earners. It's a high level of inequality and actually very similar to inequality in places that have more structural or more historically acknowledged structural issues with inequality, like South Africa, for example. But how could we play with this to demonstrate to you that inequality is a function of the distribution of people along this income spectrum? Let's say, for example, we wanted to change the number of people in each group. Let's say we wanted to, instead of just having one person in the bottom of the income distribution, let's say we wanted to have up to 200 people. By adding 200 people to the total count, I have made our society a lot less or a lot more unequal, because now even though we have $200,000 of the income at the bottom of the income distribution, right? Just giving money to the very bottom of the distribution doesn't necessarily help make everything equitable, or by just changing the amount of people at the bottom of the distribution doesn't necessarily make everything more equitable. Having a society where 200 people are making $1,000 a year is going to make inequality worse than having one where it's just one person and then another person, they gradually make more income. What we're saying here is that there's a huge portion of this economy that's really impoverished, and then some people who are emerging from that poverty, and then one person who has done super well in spite of the 200 people at the bottom. So it's not necessarily something that would be helpful to do to just add people to the bottom of this distribution. Just by doing that, I've increased the Gini coefficient from 0.75 to 0.87. But like, what if I took that same 200 people and added 50 of them to group 3, 50 of them to group 4, 50 of them to group 5, and then 50 of them to group 6. You see, even though I've taken the same 200 people, the fact that those 200 people are now making a more even spread of income, evenly growing spread of income. They're spread out across these different groups, and there is more of a representation of them across the income spectrum rather than just in the super poor. We've made more equity in our economy. We've actually bumped the Gini coefficient to 0.46, and you can see it with the Lorenz curve that our economy, because of this increase in the amount of people in the middle, is actually more equitable now. And part of that is because there's a lot of income controlled by these groups, by having 50 people make $50,000, right? We have 2.5 million just in this group of the total income made, 1.75 in this other group. That far exceeds the 1 million made by the one person at the top. 20 people making 1 million, if I was to just add 20 to this number in column B for the top group, actually brings more equity to the economy, because those 20 people represent now 2/3 of the economy making the highest amount of income. If I was to then weight that with, let's say, 200 people at the very bottom, it makes inequality worse, because now those 20 people are a small fraction of the economy making a very high amount of money. And comparatively, there are a whole bunch of people at the very bottom making a lot less money. So I just wanted to employ this example to show you how a Lorenz curve is built, how you can use the Lorenz curve to derive what we call the Gini coefficient, and then how things like the Lorenz curve and the Gini coefficient help us quantify inequality beyond just qualitative factors or anecdotal examples of people having different experiences despite having similar economic characteristics.